All right, so good morning or good afternoon, depending on where you're joining us from, everyone. My name's Jesse Hildebrand, and welcome to Exploring by the Seat of Your Pants' Biodiversity Day. So in honor of the big International Day of Biodiversity yesterday, we've had over 20 hangouts today with amazing people that are learning about and helping protect wildlife all around the planet. Some of you might have joined us a little earlier, in which case, welcome back. So right now, we have 5 classes from across North America. I'm going to give them a chance to do a bit of a shout out, and then we'll go from there. So first, we have Mrs. Olson's grade 5 class from Rochester, Minnesota. They're so excited they break the internet. All right, we have Mrs. Betts' grade 8 class from Rockwood, Ontario. I think someone started that with howdy, which is outstanding. Okay, we have Mr. Ruffin's grade 5 class, also from Rochester. Awesome. We have Mrs. Gutowski's grade 4-5 split from Campbell, California. He is awesome, I know. Ari is awesome. We're going to get to him. And then Miss Castell's grade 3 class from Freehold, New Jersey. Your mic is muted, but we can feel it. There we go. You're good. Hello, guys. Hi. Awesome. So a little bit of everywhere today. Of course, the reason you guys are all here today is not for me. It's for our amazing speaker, Ari Friedlaender. So he gets to research and do amazing stuff in some of the coolest places in the world with some of the coolest tech in the world on marine mammals. So if you've ever seen a whale getting tagged or a cool camera on its back or all sorts of neat stuff, it's probably him. So without further ado, I'm going to turn it over to Ari, and he's going to blow our minds with some really neat stuff. So thanks so much for being with us here today, Ari.
Well, thank you, guys. That was a pretty awesome introduction. I'm glad everybody's excited. I think the thing I've learned so far is that 5th graders have a lot of energy, which is great. I'm excited for that. So what I thought I would be able to showcase for you guys today is how we research whales and how we study animals that live underwater. You can't see them at all except when they're at the surface. So we've come up with some really neat ways to use technology to study whales. So I'm going to give you guys a presentation to talk about the tags that we use and the equipment we use, and show you guys some videos of what it looks like to tag a whale, and then what the data show us. And then you guys can ask all kinds of questions about what you've seen. So I'm going to share my screen right now, and I'm going to start a PowerPoint presentation that hopefully you guys will be able to see. So
perfect. Yep.
You guys can see that? Okay. Excellent. All right, so here we go. So this will probably be about 10 or 15 minutes worth. And what we're going to do today is look, basically seeing below the surface, how we use tag technology to study whales in the Antarctic. This is my lab, and I'm at Oregon State University, and I also work with UC Santa Cruz in California, so we work up and down the coast. So who here knows what this is? This is a pretty obvious animal. This is a leopard in Africa. And if you were really smart, you'd study things on land. So if you were to go out on a safari, you could see this leopard wake up in the morning. You'd be able to watch her climb down from a tree, go out, stalk an animal, maybe take it down, and then feed it to her cubs, and then go back and rest. And you'd be able to watch that happen in real time and consistently, and you'd be able to visualize it the whole time. Unfortunately, if you study things in the ocean, you don't have that opportunity. So what you're seeing here, this is a picture of Antarctic minke whales. These are small whales. They're about 20 to 25 feet long, and they're only at the surface for about maybe 1 or 2 minutes every hour. And when they're at the surface, typically all they're doing is breathing. These are mammals that need to breathe air, but everything else happens below the surface. So in order to understand what these whales are doing in their natural habitat, we have to come up with ways to study them when we can't see them. And if you look really closely at the animal in the middle of the frame here, you'll see a little green thing on its back. And that's one of the tags that we've developed. So this is a close-up of that animal. You can see that little green tag on its back. And this is essentially what lets us ride on the backs of whales to see what they're doing when they're feeding, how they interact with each other, how they navigate around different things in their environment. And it's a tool that we've been using for about the last 10 or 15 years. And it's very similar to a smartphone that has lots of different sensors in it. So here's this video. You can see us putting a tag on a humpback whale in the Antarctic. So these tags attach to the whales with suction cups. It just slaps right on their back. It stays on the animals for about 1 or 2 days at a time, and it's non-invasive. So the animals really don't even notice that the tag is on there. On the bottom, you can see we've got lots of different colors and different types of tags. Some of them have video cameras on them. Some of them have microphones. But essentially what they do is they record all of the movements of the animals continuously for 1 or 2 days. Then the tag falls off of the whale, and you see that little tail on the back of it. That's called an antenna. We use that antenna to help locate where the tag is when it's off of the whale. We then go retrieve the tag, we plug it into a computer, we download all of the data, and then we get to see what these animals are doing. So I thought I'd show you guys a few videos of what it looks like to put a tag on a whale. So here we are off of Cape Cod, off of Massachusetts. These are whales that are blowing a bubble net at the surface. There's a humpback whale that just jumped out of the water. And you're about to see 3 or 4 whales surface right on the left part of the screen there. All of their mouths are open, they're filled with fish. And we're going to approach really slowly. And when that whale shows me its back, I'm going to put that tag right on the back. So these are humpback whales. That's the mouth that's above the surface right now. You'll see the blowholes in a second. Right there, it's about to take a breath and show us its back. A nice breath, there's the back. And we put the tag on the back of the whale, and then it goes and it swims off. I'll show you a few more because different whales behave differently depending on what they're doing. So this is putting a tag on a humpback whale in a place called Wilhelmina Bay, which is in the Antarctic. One of the places that we do our research is in Antarctica. It's cold, it's generally not very great conditions, but the whales there are really approachable. They're curious about us. They oftentimes will sleep at the surface, and they let us approach very closely to them. So the tag that we're using is on the end of this pole. It's about a 20-foot pole made out of carbon fiber, so it's really, really lightweight. You can see these animals are sleeping, so we approach them really nice and slowly. And when we get close enough, you'll see that I just slap that tag onto their back. So be quiet. We don't want to wake up this whale here. There we go. That whale was basically asleep when we put the tag on it. So one thing that we make sure we do when we approach the whales, we never put our boat on top of their tail or any part of the whale. That would be very dangerous. So here's a second deployment on another animal. You'll see we're coming right up from behind this animal. You'll be able to see the flukes of the whale just in front of me, just underneath my hand in a minute. The little white thing is the dorsal fin of the whale. There we go. We slap the tag right on its back. So this was great. The whale really didn't even respond. It hardly knows that the tag is on its back. And now we'll get to see what happens when that whale wakes up. So here's a humpback whale. These whales are about 40 feet long. They weigh about 30 tons to 35 tons. You can see this one's got barnacles all over it. All those little white things are scars on the animal. You can see the eye right here. This is really cool. The whale got very curious. It came to visit us and see what we were doing. Came really close to the boat. They're very gentle animals. They know exactly where their bodies are. And look there, you can see our tag on its back. That little tag is going along for quite a ride. And you can also see how small that tag is relative to the whale. These guys are absolutely enormous. All right, now here's us putting a tag on a different species called a beaked whale. This is off the coast of California. Notice how we're going really fast to catch up with these animals. This is a little bit more of an active pursuit because these animals dive for over an hour at a time, and we only get one chance to put a tag on them. So this is from the driver's perspective. I'm telling him to slow down now. I can see the whales ahead of us. We don't want to scare them too much. I said how far I think the whales are from us. We're now going to slow down, and I'm going to point to where I see the whale underwater. And if we get lucky, the animal's going to come up and we can put a tag on it.
Now on the right, the animal up on the right. Okay. Okay. Okay.
So watch quickly. It's going to happen really quickly when the animal surfaces.
Nice job.
That was great. And now watch this. We missed the high five. We're really bad. But that was a great tag deployment. I'll show you one more. This is on a blue whale. This is the biggest animal that's ever lived. This animal is probably about 80 feet long. It's about twice the size of a humpback whale. And this is off of California, off an area called Long Beach. Blue whales, when they're at the surface, are pretty mellow. They let us get up very close to them. And you'll see we approach nice and easy up to the whale and put the tag on its back. The whale takes a breath, we accelerate. Look at how big that whale is. It's absolutely enormous. You can barely see the tag on its back there. This whale's going to surface in a second. You'll just see how big this animal is. They're absolutely incredible. There it is. There's the tag on its back. All right. So now that we've put the tag on the whale, we need to get it back and see what these whales are doing underwater. Here's what it looks like from the whale's perspective. So this is a camera on the back of a blue whale. And what you're going to see is the animal is going to open its mouth really, really wide in a second. And it's going to take in a huge mass of water that's got lots of krill in it. The animal's accelerating. It's getting towards the surface. There it opened its mouth. And on the right-hand side of the screen, you can see that thing that looks almost like a car tire that extended. That's the underside of the mouth of this blue whale. And all those little things that are passing by, those are krill. Those are what the animals are eating. Look at all of them. There's thousands of them. And it's amazing that the biggest animals on the planet actually eat really small food like that. But these video cameras are incredible because they show us exactly what the whale is seeing and what's happening with the whale when they feed. All right, so now one of the things that we do when we get the tag data back is we have to understand what the whales are doing underwater when we can't use the video. So we went to a video game animator, and he made us a program called TrackPlot. And what TrackPlot does is it turns the track of the whale into this little ribbon. So anytime the whale is moving around, the ribbon shows us the orientation of the whale, either going up or down or left or right. And all those little blue and red triangles that you see are when the animal is actively swimming. So you can see when the animal is gliding versus when it's actively swimming. So here's what it looks like from above. This is a humpback whale doing something called bubble net feeding in the Antarctic, where the animal goes down and it blows a ring of bubbles in a 360-degree circle and then comes up through the middle. So what this allows us to do is see over time how the animals are behaving and the things that they're doing underwater in 3 dimensions. This is if we animate the track, you can actually see what the whale is doing. So the whale is the icon here. Remember, the little red parts are when the animal is actually kicking. This animal's going down on a dive. On the right-hand side of the screen, you can see how deep this animal is. This guy's about 145 meters, which is almost 500 feet. You can see the orientation of the animal. It's moving up and down. It's circling back left and right. And all of those fluke strokes from its really powerful tail are those red and blue triangles. So right now, the animal's going to start feeding. It kind of accelerates and glides. It's going to turn back into this prey patch, accelerate and glide, and do this back and forth. And to us, this is a really good indication that this whale is feeding. The other thing that's really remarkable is this is a 40-foot-long animal, and look at how quickly it's able to turn and how tight those turns are. That's because of these big pectoral flippers that the whales have and the very powerful flukes that allow it to move in very tight circles. So that's a humpback whale. Sometimes we put tags on mothers and their calves, and we can see how animals learn different behaviors from each other. So the yellow track is the mother, and the blue track is the baby. And you can see that the baby is following right next to mom, basically mimicking everything that she's doing, going up and down with her, up and down. And then they come up to the surface, and you can see that the calf on the left it's doing a lot more kind of wiggling around at the surface. It's smaller. If you think about a puppy dog, or if you've got a little brother or sister, they tend to roll around a little bit more and just following mom. But this is a really cool opportunity for us to see how whales navigate, how close they stay together, and how they can coordinate their movements between each other. So this is really useful information for us. So those were humpback whales. I'm going to now show you what a blue whale looks like. Now this is sped up, so it's not as fast as the whales move, much slower than this. But remember how tightly the humpback whale was moving. This blue whale is twice as big. And you see that the roller coaster that it's on is way more deliberate. It's much bigger movements up and down in the water, up and down. And that's the animal feeding and then coming up to the surface. So different species have very different behaviors. And when you have this track plot, you can compare how blue whales feed versus how humpback whales feed. Now, one thing we've learned about this bubble net behavior that I mentioned before is how it actually happens and how the animals actually do it. So here's an animation of a whale off of Cape Cod blowing a bubble net and doing its feeding behavior. So it's in the middle of it now, and I'll sort of walk through what happens. So the whale's at the surface. This whale dives down, it rolls over onto its side, it starts to blow bubbles right now, and it makes a 360-degree loop of bubbles. She comes to the surface, and then she slaps the water with her flukes right there, then goes down and makes another quick circle and comes up through the middle of it. And that's a very typical behavior that this animal does, and she does it over and over and over again. What we found, which is really cool, is if you tag a lot of different animals, you find out that whales have their own personality. So in the top left here, that one that's called 189B_04, that one makes two sort of concentric bubbles down at the bottom that are at the same depth. The one next to it kind of does this 3 loops and a corkscrew. The next one over does 2 loops and a corkscrew. The one on the right, I have no idea what's going on. That almost looks like an animal that doesn't know what it's doing. But the more you study these animals, the more that we find out that they have their own unique styles of feeding. Someone, you know, in your family, you might eat pizza with your hands, where someone else in your family might cut it with a fork and knife. So the more times we put out these tags, the better we understand how individual animals feed and how each one can be identified. We also see that these animals do really cool things like feed on the bottom. This is a humpback whale going down to the bottom. The yellow part is just where the animal rolls over onto its side. So right there, it's kind of digging its face into the bottom and pulling up food from the sediment. And this animal will do this over and over and over again. Just like with bubble net feeding, here are 4 different whales that are doing bottom feeding, but doing it in really unique ways. Each animal has its own identity and feeds in a different way that makes sense for it. So it's really cool to think about whales as having this personality or being individualized in what they do. Now, I want to end with how this information can be useful for us. And one of the things that's a problem is that humpback whales live in places where there's a lot of human activity. There's a lot of shipping traffic and there's a lot of fishing activity. And what this tag data can tell us is how often whales are spending time at the surface, or how often they're spending time in deep water or near the bottom. And if we can understand where ships are at different times of the day, or where fishermen put their fishing gear, we can tell them that humpback whales need to be in the surface waters from 8 in the morning to 5 in the afternoon, or they need to be using the bottom water from 5 in the morning till 3 in the afternoon. And if you can tell people this, then we as humans can change our behavior so that we don't do the things that can negatively impact a whale. Sometimes these whales get struck by ships, or they get caught in fishing gear, and those can be really, really bad for these animals. So if we can figure out ways to conserve these animals by understanding their behavior and telling fishermen or boaters where to use gear, where not to use gear at different times of the day or night, it can mean a lot for these whales. And protecting these animals and the habitats that they live in is one of the things that's really important to us. So that's what I wanted to talk to you guys about today. I hope that was a really useful presentation, and I'm going to stop sharing my screen now, and we'll let you guys ask some questions.
Awesome. Thank you so much. I love that you can catch a whale with really delicate maneuvers at 30 kilometers an hour, but then you miss the high five. All right. So we'll start with Mrs. Olson's class. If you guys have any questions, come on up.
Okay, so
Go ahead.
You said that a whale can dive 400 feet down, but the tags stay on for 2 days. How does the tag not fall off with all of the water pressure?
That's a really good question. You know, what we think happens is when the whales actually dive deep, all of that pressure, it makes the tag actually stick better to the whales. And so that suction cup has a little bit of air in between it and the animal. And when it dives deep, that pressure compresses all of that air and the suction cups stick really good to the whale. That's a really good question.
That is a really good question. All right, let's go to Mrs. Bett's class. You guys have a question?
What is your Navy sonar and how does it work?
I'm sorry, I couldn't quite hear the question. Can you repeat it?
There was something in your blurb about Navy sonar. So what is Navy sonar and how does it work?
Sure. So one of the things that we're trying to understand is how whales respond to different things in their environment. And whales use communication in the ocean with acoustics, with sound. You guys can't see very far in water. We can see really well in air, but sound travels very good in water. And so whales use sound to communicate mostly with each other. The navies use sonar to find submarines. So what they do is they make a very loud sound that goes out from a ship. It bounces off of something in the water and bounces back to them. And the echo that returns tells them what's in front of them. And that's how they locate submarines. Unfortunately, the sound that those ships make is right in the hearing range of where whales are. And that can be a very loud sound, and it can be either a disturbance to the animals or it can scare them. And so what we're trying to understand is how the whales respond to these kinds of sounds. One of the things that we found is that the whales, if they are feeding, will stop feeding if they hear this sound and move away from an area. And that can be a big problem because whales can't really afford to miss a meal. If we miss a meal, you can just go back into the kitchen later on and get the food you want. But for a whale, the food is only available sometimes. So if they get displaced or if they get disturbed from these kinds of sounds, it can mean that the animals don't get enough food.
Excellent. For that class too, I know you guys are fairly close to the Royal Ontario Museum where they have a giant blue whale exhibition right now where they really go into that in a lot of detail too. So if you get a chance to visit, you should. All right, Mr. Ruffin's class, if you guys have a question, go right ahead.
Can whales live in freshwater?
Can whales live in freshwater?
So cetaceans, which are whales and dolphins and porpoises, are all considered marine mammals. There are a few species of dolphins that actually live in rivers. There's some that live in the Amazon River. There's some that live in the Ganges River in India, and they have adapted for life in fresh water. There are no big baleen whales, though, that live in fresh water, but there are a few dolphin species that do live in fresh water.
Excellent. All right. I think Mr. Moore's class in Toronto did come back. Is that correct or not? No? All right. We have Mrs. Bobby Fromm's class. If you guys have a question,
yeah,
go right ahead.
All right. Marcel, go ahead. Speak up, loud voice.
Are there any predators for whales?
Do whales have predators?
That's a great question. So I'm in Monterey, California right now, and there are gray whales that have just given birth in Mexico about a month ago that are now migrating up the coast up to Alaska to feed. And there are killer whales that are sitting right offshore in Monterey Bay waiting for those whales to pass through. And killer whales will attack other whales. Occasionally, sharks might attack on a small dolphin, but once you get to be the size of an adult whale, there's nothing in the ocean that can attack you. So you're pretty safe if you can get to be that big. But sometimes smaller whales get attacked by killer whales. That's how they got their name.
Awesome. All right. So I can't demute either of your microphones, but we'll start with Mrs. Costell's class. If you guys want to come up and demute your own mic, you can ask your question. Take your time. There you go. Perfect.
Do you tag any other animals?
Do I tag any other animals? I'll tell you what, there are so many whales and so many places to go and work that keeps me 100% busy. We've tagged about 15 different species of whales and dolphins, though, around the world in the last maybe 10 or 15 years. And there's a lot more species out there that we haven't tagged yet. I've been around some friends that have put tags onto mountain lions and leopards and been able to see that, but I focus mostly on whales.
Awesome. All right. And then last but not least, Mrs. Gutowski's class, if you guys can demute your own microphone and come on up, you can ask a question.
Right. Can you hear us?
Yep.
Right. How many whales do you think you tagged?
I tried to add it up last year. The closest I can get is to about 500 whales that I've tagged.
Wow.
Is that all?
My arms are really tired from carrying that pole, though. Yeah.
Awesome. All right, guys. I know that you probably guys have lots of questions. We could probably go back through all of them. We're almost out of time. It's almost 3 o'clock, so some classes need to go home in a minute. So what we do at the end of every Hangout is I'm going to demute everyone's microphone. So Miss Olson, Miss Betts, Mr. Ruffin, Miss Fromm, everyone. And if you guys can join me in saying a big thank you. It's so excited, it just becomes white noise. All right, so for the classes, thank you so much for joining us today for our International Day of Biodiversity. We'll be doing more Hangouts in May, more in June. We have a huge World Oceans Day on June 8th if you'd like to join us for that as well. And just thanks so much for being here. Ari, that was outstanding. Thanks for joining us.
My pleasure, guys. Thank you, and I hope to see you guys out on the water sometime.
Awesome. Have a nice day, everyone.